Number 1, what did we get?
Oh.
When you add those two together, what do you get in number 1?
You got one correct.
I'm asking for the answer to number 1.
I don't know if it's right, but I got 7 minus 2x.
7 minus 2x is correct. So when you are adding these, one of the easiest ways I think to add these binomials is to line them up so you have like terms stacked on top of each other. So like 2 minus 3x, 5 plus x, line them up and combine. Get 7 and negative 2x. What about for number 2? What did we get there? 1 minus 7x. With number 2, since it is subtraction, you have to distribute this subtraction here. That would give me negative 6 and negative 4x. You don't change anything at all about the first one. Line them up and combine. So 1 and negative 7x. On number 3, we're not adding, we're not subtracting. What are we doing on number 3? Multiplying. So double distribution. In Algebra 1, you might have used a box or an area model to help you with your double distribution, but you're going to take everything inside this first set of parentheses, both pieces, and they get distributed to both pieces back here. So I would do 2 times 5 first. What's 2 times 5?
10.
10. And then I would do 2 times x, which would give me 2x, and that's a positive 2x because they were both positive numbers. Then I take this negative 3x and I distribute it to both pieces. What's negative 3x times 5? Negative 15x, because we had a negative 3x that we were distributing. What about negative 3x times x? Negative 3x times x. Negative 3x squared. So just kind of a side note over here. X plus x is 2x. X times x, when we multiply, that's when the exponent changes. So if you are adding, it is the coefficient that changes. And if you are multiplying, it is the exponent that changes. Right? All right, so going back to this problem, because we're not quite all the way done with number 3, have we combined all of our like terms together? This is where I left off. 10 plus 2i, sorry, not 2i, 2x. I'm getting imaginary numbers stuck in my head here. That should have been 2x. 10 plus 2x minus 15x minus 3x squared. Have we combined all of our like terms together? What can we actually put together? 2x and negative 15x. In order to be able to combine them, like terms has to have the same letter and the same power, the same exponent. So these both have x's and neither one has an exponent on it. Nothing combines with my 10. What is 2x minus 15x? Negative 13x. And then this minus 3x squared doesn't have anything to combine with. So that would be my fully simplified answer. Do you guys have any questions about the bell work? Yes, sir.
Now, if 13 and 3 were like 4 and 12, could you simplify it more in other terms?
Like if everything in here was even?
Yeah.
If everything in there was even, we could technically pull out a greatest common factor, a GCF, but you wouldn't need to on this problem. It didn't ask us to do that. Could you? Yes. Is it required? No. Do you guys have any other questions for me about the bell work? Because this idea right here, this is what we're going to be doing today. Here we practice doing it with x's, with binomials, things that look like Algebra 1. Do you guys remember what we learned about in class yesterday?
Yeah.
Imaginary numbers. What do we use to represent the imaginary number? I. We're going to talk about adding, subtracting, and multiplying with imaginary numbers. Page 161 in your books, please. All the way down at the bottom. Very, very bottom of the page. So page 162, very, 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 very bottom. Sorry, I think I might have accidentally said 161. There's a little box down at the bottom that says key concept, complex numbers. Complex numbers are any numbers that we can write in the form a plus bi. So a plus bi is what our complex numbers look like. This part right here, the first one, this is a real number. This is a number that you could put into your calculator. Could be a fraction, could be a decimal. For what we're doing today, I think they're all whole numbers. But these are real numbers. This part of it back here, the bi, this is the imaginary number. So we have a real part and an imaginary part. It does not have to be addition in between the two parts. Sometimes it's subtraction. That's okay. So complex numbers add on to all the other types of numbers that you guys have worked with before. If you look at the top of page 163, it has some colorful circles and boxes there. So I want to talk about what these colorful circles and boxes mean, and we're going to give examples of these different types of things here. So real numbers, examples of real numbers. This n in the circle that's in the middle, right here. This is for your natural numbers. These are the numbers that you learned when you were itty-bitty, when you were first learning how to count. And when you were first learning how to count, what's the first number that you use when you count? 1. So 1, 2, 3, 4, 5. Just your whole counting numbers like you guys worked on in kindergarten and first grade. This slightly larger light green circle with the W in it, that is for whole numbers. This is all your normal counting numbers, 1, 2, 3, 4, 5, but it also includes 0. Because little kids don't usually know about 0 yet. If you're going to count blocks, we don't hand them nothing and say, how many blocks are there? They're like, there's no blocks, you're crazy. This larger dark blue circle here that has a Z in it. This is our integers. Integers are whole numbers, but it's positive and negative whole numbers. So some examples of integers would be 2 or -4 or 0 or 7, -13, any whole number that you can think of, positive or negative. Q is our rational numbers. And by rational numbers, I mean things that we can write as fractions. So numbers like 1/3. Or I can write them in decimal form. If I can write them as a fraction, I could also choose to write them as a decimal. So 0.5 would be another example of a rational number. 1.75. Things that have decimals that have a pattern that repeats, like 1.479, 479, 479, on and on and on. If it has a pattern in the decimal, we can write it as a fraction, so that counts as a rational number. So far, so good? This one over here, this I, stands for irrational. Examples of irrational numbers.
You got a pen?
Yeah, you said a pen. Irrational numbers, things that we can't write as fractions. Have you guys heard of pi before? Pi is about how big? 3.14. Does it stop there? Yeah, 3.1415 something. That's as far as I know it. But I've got a poster where they've got it written out. The individual numbers themselves, like 1, 4, 1, 5, there's some repeats there, but there's no pattern to the repeating. Irrational numbers don't have any pattern when you write them as decimals. That's why we write this one with just the pi symbol. Another example of an irrational number, something that doesn't have a pattern when the decimal repeats, is the square root of 2. If you put that into your calculator and you make it tell you a decimal, it'll just go on and on and on and on and on, and there's no pattern in those decimal pieces there. So all of this right here, these are all numbers that you guys have used in the past. These are real numbers. Yesterday we added on imaginary numbers. So we had our pure imaginary numbers, I, or negative 3i, or 5i, 2i. Anything with an I would be an imaginary number, a pure imaginary number. When we take a real part, so something that is a whole number or a fraction or even an irrational number, and we put that together with an imaginary, this is a complex number. So far, so good?
Wait, you said W was an N weren't?
So N means, I don't know why your book did this. It's such a fine point difference, and not every mathematician agrees with this. N means your natural numbers. These are the numbers that little kids learn first when they're learning how to count. 1, 2, 3, 4, 5, all of those. W is whole numbers, which is all your normal counting numbers, but you also include 0. My 6-year-old daughter just learned about the concept of 0 not that long ago. Up until then, she was just counting how many things are there. Sometimes you give them a piece of paper, like in her first grade class, it's like, how many bears are there, how many blocks? And it might just be 6 blocks. 0 bears, 6 blocks. Z is your integers. This is really where we pick up for things like Algebra 1 and Algebra 2. Integers are whole numbers, but we include positives and negatives there. Does that make sense? Okay. We're going to do operations with complex numbers, and it works just like what we did on the bell work. We are not going to do example number 4 in your book. In fact, we're skipping a whole bunch of stuff in your book because they either do the most and make it way more confusing than it needs to be, or it's just straight up a bad example and I've got my own. So we're going to go over to page 164. We are going to do their example number 5. What do they want me to do with these two complex numbers? What are they asking me to do between them? Subtract. We want to subtract these two. So I need to distribute the subtraction here. If I distribute that subtraction, what would I get? -4 and a positive 10i. I'm going to take the first number right here. We're not changing anything about that one at all. 8 plus 3i. I'm taking this -4 plus 10i. We're going to combine them together. What do I get when I combine the real parts together? Yes. We get 4 plus, and then we combine our imaginary parts together, 3i and 10i, gives me 13i. That's my final answer. Your book is doing all kinds of other crazy stuff. This gets you the right answer. Distribute your negative, combine the real parts, combine the imaginary parts. Done. Do you guys see that check that's right underneath example 5?
Yep.
I want you guys to try that one on your own. To learn how to do it if you don't even have your book open, sir. We're on page 164. I understand. No, you did it right. They wrote it dumb. This is why I don't like your book. What'd you guys get for the real part here? When you combine the real parts together? -2. What about for the imaginary part? -3. Your book had a plus sign there, but it should really be a minus sign. So -3. Because we've got -5 plus 5i. We have to distribute our subtraction here, so that would give me 3 minus 8i. And then when we combine those pieces together, we get -2 minus 3i. Does that look like what you got? All right. The book had a plus sign in it. It should have been a subtraction sign because you should have gotten a -3i. So I changed it to a minus there. Chloe, you look confused. Where did I lose you?
Where are you?
We're at the check right underneath example number 5. So before example 6.
Oh. Okay.
Yeah. It's like just squeezed in there because these examples are really, really small. Do you guys see the purple box and the blue box over in the margin? You see how there's just like 3 lines in between there?
Yeah.
We're going to do an addition problem there. Because your book only had subtraction examples. So I want you to put this in the margin. Yes.
Why didn't the negative go to the -3?
It did. When you have a negative and a negative together, it changes it to a positive. All right, so in between the purple box and the blue box, in those couple of lines right there, I want you to put this problem. So I've got 7 minus I plus 12 plus 2I. I want you guys to add this into the margin in between the purple and blue boxes. Do I have to distribute a negative with this? So what am I going to get when I combine the real parts and I combine the imaginary parts? For which part, real or imaginary? There's going to be a plus 1I. What about when I combine the real parts together? 19. When we're doing this addition, all we have to do is line the real parts up, line the imaginary parts up, and add them together. 7 plus 12, I get 19. Negative I plus 2I gives me I. I don't know why your book didn't have an example of addition, but they didn't. We are not doing either of the other examples that are on this page. We're going to copy some stuff into that larger margin underneath the blue box. I'm going to put those problems up here in just a minute, but example 6 is really confusing and doing the most, and example 7 is something that we are not covering in Algebra 2. So we're not going to do either of those examples. These are the two that I want you guys to write in that left-hand margin underneath the blue box. Yep. You guys have lines underneath the blue box that extend down to the bottom of the page. That's where we're going to do these two. What operation are we doing here?
Multiplication.
Multiplication. So I'm multiplying these things together. That means I need to double distribute. If you used an area model, a box, in Algebra 1 to help you with this, you're welcome to use that here. I'm not going to write it like that up here on my screen because I just don't have a lot of room for both problems. But that means I'm going to take this 3 and I'm going to distribute it to both pieces. What's 3 times 5? 15. What's 3 times I? 3I. So plus 3I. Then I still need to distribute what?
6I.
Yep. Negative 6I has to get distributed to both pieces. What is negative 6I times 5? Negative 30I. What's negative 6I times I? Negative 6I squared. Do we have any like terms that we can combine together? Yes. 3I and negative 30I. What do I get when I combine those two together?
27.
Negative 27I. And then we still have this minus 6I squared here. I is the imaginary number, but I squared is special. Does anybody remember from yesterday what I squared is equal to? Super close. What'd you say? She said 1.
Oh, negative.
Negative 1. I squared is equal to negative 1. So whenever I see an I squared show up, I am going to replace it with a negative 1. What's negative 6 times negative 1? Positive 6.
Can't you add the 15 and the 6 together?
Absolutely. And you have to, or you're not done simplifying. The 15 and the 6 are like terms, so we're going to combine them. What is 15 plus 6? So I have 21 minus 27i. That is fully simplified. Because I can't simplify I any further, but I squared I can. For this second one, I want you guys to try it on your own, and then we'll check your answer against mine. So I want you to do this example right here in the margin. Follow the same pattern that we did here.
Quick question. These two cancel out, so it's just a 0.
Miss Bo,
Yes, sir.
on the 3i, don't you have to times it by 2? Wait. To make 2 equations.
It's 2 times.
Don't you do 2 times 2 and then 2 times 3i? 3i times 2.
2 times 2 and 2 times negative 3i.
Yeah, that's what I said. And then 3i times 2 and 3i times negative 3i.
All right, so I end up with 4
And I'm right.
minus 6i, but then what else do I have to distribute?
The plus 3i.
Positive 3i gets distributed, so then I have
So I'm right.
plus 6i minus what? Minus what?
Minus negative 9.
Yep, minus 9i. I times I gives me? It's not 9i, it's 9i squared. There we go.
Man, that's the only thing I didn't know. Everything else I knew.
Yep.
And you got the problem. Erase the whole thing.
Do we have any terms that we can combine together?
Yeah.
Yes. We can combine the negative 6i and the positive 6i together. What happens when I combine those, though? They cancel out. So I have 4 minus 9i squared, but what do I always replace an I squared with? Negative 1. So this is 4 minus 9 times negative 1. What is negative 9 times negative 1? Positive 9. So I have 4 plus 9. 13. What's different about the results of this one and the results of the previous one? It doesn't have I. This is just a real answer. Back here, when I double distributed and I combined my like terms, I still had I. But here, my negative 6i and my positive 6i canceled. I squared is a real number. And so we replaced it with negative 1. That is everything I've got for you for today. For real, that's it. There is homework that is due tomorrow. I put it up on the board yesterday. It's not any different than what I had up on the board yesterday. 3-3 homework is due tomorrow. Huh? That's it for today. Pages 165 and 166 is where you can work on them in your books. These are skills from yesterday and today. 3-1 homework, I had to, if you saw that show up as like a different due date, I had to extend that because some people it wasn't letting them in. So that one had a due date of yesterday that I had to change it to. If you are having difficulties getting into any of the McGraw-Hill homeworks, please come and work with me. One other thing. Do you guys remember last Thursday when you had the graphing homework that was on paper? It was problems 10 and 11 on the back of the packet where we did graphing on paper, not in your book. That homework, I haven't had the opportunity to come around and check. What I want you to do to get credit for that is snap a picture of it with your phone and upload it to the Canvas assignment. That way it's impossible for me to misplace it. All right? Snap a picture of the paper homework. It was problems 10 and 11 on the back of the stapled page where we did graphing practice. Snap a picture, submit that to the Canvas assignment.